Hello students, let us try to understand the problem number 10.2 students. What is? They are saying anhydrous aluminum chloride is covalent where its aqueous solution is ionic. Okay. So if you talk about the first case, we are talking about anhydrous AlCl3 and aqueous, okay, aqueous AlCl3. In the aqueous solution, students, it exists like that Al3 plus 3Cl minus in the form of ions. So since in the aqueous solution it is in the form of ions, that is why it is the ionic. But here you apply the Fajan rule, student. AlCl3, this is the positive, 3 positive charge. And what the Fajan rule is saying, student, that greater the positive charge, what they said is, student, greater the positive charge, greater the positive charge and greater the positive charge, so greater the polarization, so greater the polarization, greater the polarization of anion, greater the polarization of anion, and hence what, student? And hence greater covalent character, greater covalent character. So dear student, you might have understood Fajan rule. If you know the Fajan rule, then only you can be able to answer Fajan rule. Okay, Fajan rule is saying, although it is ionic only, but Fajan rule is saying because of the small size of cation and more charge density, it attracts the electron of chlorine, that is chloride ion, in the center and develop the covalent character. In another word, you can say that it is polarizes the anion so that it is developing the covalent character. But if you talk about aqueous solution, it is existing in the term of the ion Al3 plus and Cl minus, so that it is what is known as, student, this is the ionic. Okay, so let us have here the look, students, what is the answers for these questions. They are saying, student, aluminum form covalent compound with the chloride because ionization enthalpy of Al3 plus ion is very high. Chlorine is unable to convert Al into Al3 plus ion. Okay, here is the, they are saying that is, okay, enthalpy is 5137. However, when anhydrous Al3Cl3, okay, which is the covalent character, dissolve in water, it undergoes hydration, so that is they will give the ions. Okay, hydration of anhydrous aluminum chloride is highly exothermic in nature. The hydration enthalpy is more than the ionization enthalpy of aluminum. This hydration enthalpy remove all 3 valence electron of the aluminum, leading to the formation of Al3 plus ion. This Al3 hydrated water, thus water Al exists this form. The 3 electron aluminum accepts by Cl, and thus hydrated aluminum chloride is ionic in nature. So dear students, firstly the reason is not that much of the correct they have given in the book, but if you know the Fajan rule, you can easily explain that AlCl3 is covalent compound. I know they have a more greater covalent character because of the smaller size of the cation and higher charge density, it is having the more polarization. In aqueous solution, it get dissolved because of the high hydration energy. Okay, and it form the Al3 plus and 3Cl minus, and that is what is the ions develop, that is ionic compound. Thank you so much for watching, friends.